Okay, on this page, this is where I want you to notice the difference in the directions for the problem. This one doesn't say rewrite, it says find the value of the following logarithms by rewriting as an exponential. So for this one, we are actually trying to get an answer or solve the problem. So remember that for most of the problems that we're looking at here, if it's given as a log, we're going to want to rewrite it as an exponential. And if it's given as an exponential, rewrite it as a log. So these are given in logarithm form, and we want to write it as an exponential. So that means we're going to be doing the E shape for exponential. So what I like to do when I'm given an expression like this to find the value is to put in an equals x here. And the reason for that is because it's just going to make it easier to rewrite and follow that pattern that we've been doing. So we know if I have log of 1,000 that we have that implied base of 10. And if I want to rewrite this, then the 10 is the base. It's going to raise to the power x equals 1,000. And in a later lesson, we're going to talk more about the principle that is behind what I'm going to show you how to do now. But for now, I'm just going to tell you if we can write the expressions on both sides of this equation where they have the same base, then we're allowed to drop the bases and set the exponents equal to each other. Because right now I have the variable x in the exponent and I don't really have any tools to be able to solve that. So what I'm going to do, since this is 10 to the x, I'm going to write 1,000 as a base of 10. And if I have 10, we would have to raise it to the third power to get 1,000. And now because the bases are the same, we can drop the bases and just set the exponents equal to each other. So the value of that log expression is 3. So the second one is going to work the same way. If you want to draw in the implied 10, you can do that. And then if I make my E, I know the base is 10. I'm going to raise that to the power of x. And then it's 1 over 100. So this one is a little more involved. I'm still going to try to write that 100 as a base of 10. So that would be 10 to the second. But I can't drop the bases because right now I have a base of 10 and a base of 1 over 10, which are not the same. But remember, with my exponent rules, if I have 1 over 10 to the second, we can rewrite that as 10 to the negative 2. Remember, with exponents, if we want to change where the expression is in the numerator or the denominator, we have to change the sign of the exponent. So then my bases are now the same, so I can set the exponents equal to each other, and I get x equals negative 2. So those two problems were kind of nice because we were given a number that could be written as a base of 10. But what happens if we need to evaluate something that we can't easily rewrite as a power of 10. Well, we could estimate and look at log of things that are close to 9 that we can rewrite as a base of 10 and make an estimate. But luckily enough, the calculator will actually do log base 10 for us. So whatever calculator you're using, you should have a button that says LOG. So we should be able to go to our calculator, find that log button. On my calculator, when I push it, it comes up and says log and puts up a parenthesis, and then you just enter 9 and close the parenthesis. And I think I got 0.9542. And since I didn't put anything in here about rounding, we can just leave it as that, okay? Alright, so the ones that we've looked at so far have all been a log with a base of 10. But of course, 10 is not the only base that can be. So this part we're just going to expand into more bases. Your calculator cannot handle a logarithm of base anything but 10 or another that we're going to talk about in another lesson if it's log E, which is the natural log. So for these, we're going to need to rewrite them using this definition. If I have log base A of x equals y, then same thing that we've been looking for with the base of 10. We can make our E, and you see that that gives me the base A raised to the y equals x. So it hasn't changed. We're going to be rewriting them the same way. This just shows that it applies to other bases. Alright? So you see that the directions here are back to rewrite. So we're not solving, we're just trying to write it in the opposite form. So it's given as a log. We want to rewrite it as an exponential. So we're going to be using the same process. My base is 4. It's going to be raised to the power of 3 equals 64. And again, notice that this is a true statement. 4 to the third power is 64. So you should end up with a true statement when you rewrite these, okay? Same idea for number 2. I have a base of 2. We're going to raise it to the power of negative 4 and equal to 1 over 16. And again, this is a true statement. 2 to the negative 4, we would have to take the reciprocal, would be 1 over 2 to the 4th, which is 1 over 16. And then the last one, I have 11 raised to the power of x is equal to 3. Alright, so that's all we do with those. We're just rewriting them. And of course, this next part, again, we're just rewriting. This time it's given as an exponential. We want to write it as a log. So that means we're going to be using that L shape we looked at before. So this is the one that we follow around this way. So we have log, it's going to be base 3. Then the 9 is equal to 2. And that's all we do, we're just rewriting it. So for this one, it's going to be log. The base is 5. It's of 1 over 25 is equal to negative 2. Alright, so the next ones, these again are changing to find. So what we're going to need to do is first rewrite them, and we're actually going to be looking for an answer or a solution this time. So if it's given as a log, we're going to rewrite it as an exponential. So remember, if we're going to rewrite it as an exponential, we're looking for the E shape. So it's 2 to the x equals 32. And this is going to be the same situation we looked at with the base 10. If we can write both sides as the same base, we can drop the base and set the exponents equal. So we're going to need a base of 2. 32 can be written as 2 to the 5th. And then we can drop the bases that are alike and just set the exponents equal to each other. Alright, so these are all going to start the same way. They're given as a log, so we're going to need to rewrite them. So I get 5 to the x equals 25. So this is going to work very similar to the last one. I can rewrite both of these as a base of 5. 25 is 5 squared. And once the bases are the same, we can drop them and set the exponents equal. Alright, this one's going to be 3 to the x equals 1/9. So I can rewrite 9 as a base of 3 by writing it as 3 squared. And then we've looked at one like this previously. If we want to get the bases to be the same, we can change the sign on the exponent to move it up to the numerator. Then we can drop the bases that are the same and set the exponents equal. And then the last one, I have 16 to the x is equal to 4. So we're going to need to write both sides as a base of 4. So 16 can be written as 4 squared, and the 16 was to the x power. And then if you want to write it in, remember that this is 4 to the 1 if you want to see that. So we can drop the like bases and take the exponents and set them equal. And then if I divide both sides by 2, I get x equals 2/2. Alright, we also have a couple of properties of logarithms that we're going to look at that will help us simplify a couple of different situations. The first one says log base a of 1 equals 0. So if you think about rewriting this one, it would be a to the 0 equals 1. And we have previously learned that anything to the power 0 is 1. That's one of those exponent rules from a long time ago. Then if I have log base a of a equals 1, if you think about rewriting that one, we would get a to the 1 equals a. And of course that makes sense, right? We know anything raised to the first is a. Now these last two, they're not going to come into play very much. But if you look at number 3 in relation to number 2, you notice, let me take this out for a minute. For this one, those were the same. And they're also the same here. So when they were the same, we got 1. The difference is this time is I have this power. So it's like the log a of a became 1. So the only thing that's left is the x. Don't be real concerned about these two. You're going to see that we're not going to be doing much with this, okay? Number 4 is basically the opposite of this one, right? Instead of it being in log form, it's in exponential form. So if the base for the exponential and the base for the log is the same, they're going to undo and leave us with x also. Okay? So a couple of things about the logarithmic function. The domain is 0 to infinity. And you notice I don't have a bracket, so it doesn't include 0. So basically